Okay, and welcome to the second video on coordinate geometry, and this time we're going to be looking at solving problems involving coordinates, straight lines, intersections, and a whole bunch of other stuff. So we can see we've only got the one descriptor here. It says solve problems involving distance between 2 points, midpoints, perpendicular lines. Like I said, there's a whole load of stuff to go in that one descriptor there, so let's crack straight on. So first of all, we've got a problem that involves two lines and the intersection of two lines. So we've got L1, which is 2x plus 3y equals 19, L2, y equals 2x plus 1. Those are our two lines. They meet at point P, and we've got some information about where the two lines meet the x-axis as well, but we'll get to those bits in a second. These two lines form a triangle. That's that triangle there, APB, and it's the area of that triangle is what we're being asked to find. So we're going to need to know the 3 points A, P and B. So let's start off with point P, and we're told the two lines intersect at point P, so let's start there. So there's our two lines. If we solve them simultaneously, and because of the form that this one in here is in, we can just take that and drop that into the first equation. There we go. Do a bit of solving, and we've got x equals 2. And being as we're looking for a coordinate, clearly once we've got the x coordinate, we're going to need the y coordinate. And so the y coordinate is 5. So that means we've got our point P, which is at 2, 5. So that's one of the points of our triangle. The next point is point A, which is where L1 meets the x-axis. So L1 being this line here. So we need to find where that meets the x-axis. So what we'll do is stick y equals 0 into there. In it goes. Again, do a bit of solving. And we've got our coordinates at point A. And we're told L2 meets the x-axis at B, so let's find point B now by doing exactly the same thing to L2. There it is, y equals 0. Do some solving. Job's a good one. And now we've got the 3 points on our triangle. At this point in time, I always think it's a good idea just to draw a sketch so you can see what's going on, because we need the triangle of APB, so we need to have a little look at what's going on with this. So if we draw the sketch, here it comes. There's our two lines, and you can see the green bit we've got there, that's the triangle that we're interested in. Now, clearly, area of a triangle is half base times height. So, first we're going to need to know is, well, what's the height of that triangle? Well, the height clearly is that distance there, and we're going to pick that up from the y coordinate of P, so we've got a height of 5. For the base, let's have a look at that distance there. So clearly, we've got A, which is at 19 over 2, or 9.5. And then we've got to add on this extra little bit here, which is a half. So essentially what we're doing is adding those two values together, and that gives us the base. And so the area of the triangle, half base times height, there it is, 25 square units. Sorted. Right, on we go. Let's just talk now a little bit about gradients of lines. And we've got a statement already on the screen saying that parallel lines have the same gradients. Hopefully that's something we know. So if I've got a line there that's got gradient m, a parallel line also has the same gradient m. And lines that are perpendicular, perpendicular means at right angles, so we've got two lines doing that. And you can see from this one, if we've got, where's my mouse, here it is, that's going across one and up m units. For our perpendicular line, what it's going is across m units and down one. So in terms of rise over run, what we're getting for our perpendicular line, the brown line, is -1 over m. So there's the rise over the run. So generally speaking, what that means, if we've got two lines that are perpendicular, first line's got gradient m1, second line's got gradient m2, then we've got m1 equals -1 over m2. Or another way of writing that would be to say m1 times by m2 equals -1, because all we've done there is just taken this, moved it over to the side, and we're creating this simple formula here. Now these are ones you need to know, and in a lot of cases, if you've got to prove that two lines are perpendicular, you need to show one of those facts, and the normal one to show is just to prove that m1, m2 equals -1. So it says, here we go, find the line perpendicular to 4x minus 5y equals 8 that goes through 3 minus 1, and again we're told a specific format that our line needs to have. So first thing we're going to need to do is rearrange that, make it say y equals, because from there, that's where we're going to pick up the gradient. So the gradient of our first line is going to be 4/5. If we know that gradient's 4/5, then the perpendicular gradient is just going to be -1 over that. So basically what that means is flip it upside down and whack a minus sign on the front. So hopefully you're happy that this -5 over 4 is the negative reciprocal of 4/5. So we're using this one here. So like, can I turn it upside down, put a minus on the front, and there's the perpendicular gradient. Now that we've got the gradient, we know it goes through 3 minus 1. So what we've got to do is just put that into our formula for a straight line, plug in the values, and then now do the rearranging to get it in the form that we want. So multiply out by the 4. Notice you have times bracket out by -5. So -5 times x, -5 times -3. That gives me the right hand side. Do some tidying up. This time it's only the 5x. Sorry, try again. It's the 5x needs to come over, and the 4 will need to go back the other way. Get myself a bit confused there. There we go. And we've got our equation of the line in the form that we want. 5x plus 4y equals c, which is that value of 11 there. Okay, so that was parallel and perpendicular lines and a simple problem involving those. Moving very swiftly on. Next one we need to know about is the distance between 2 points. So you can see from the diagram here I've got 2 points. Point A's got x1, y1, it's the coordinates. And for point B, it's x2, y2. And the distance AB, and again you might see this notation here with what's technically, those straight lines are called a modulus. You don't need to worry too much about that at the moment, just recognise that as a notation that we use for distance between 2 points. And bit of Pythagoras is the horizontal distance is the difference between the x coordinates, vertical difference between the y coordinates, and your Pythagoras written in one hit like that. So that one squared, and the whole thing square rooted. And so there's your formula for the distance AB. On top of that, we might as well just, while we're at it, have a look at the formula for a midpoint. So how do you find halfway between 2 points? And again, hopefully this is something that you're familiar with from GCSE. So the midpoint is essentially just halfway between those 2 points, which is the average of the coordinates. So if we just take the total of x1 plus x2 and halve it, you get the x coordinate, y1, y2. Halve that, you get the y coordinate. You'll notice that for the other two formulas that you had, that for gradients and for the difference between 2 points, if I just like to look at the difference formula, we're looking at a difference, so it's a minus in between the coordinates. The midpoint formula is, we're looking at essentially the mean of 2 points, so we're looking at an addition there. So just be careful to make sure that you know when you're adding and when you're subtracting with your pairs of coordinates. Okay, so here comes a problem that involves using all that information. So in this case, we're going to go for proving that this shape is a rectangle. We're going to go for it using Pythagoras. So here we go. AB. So we want the distance between those 2 points there. Chuck in the coordinates. There's my x coordinates, -1 and 7. Chuck in the y coordinates. That's 5 and 1. And we end up with our answer there. It's always easy to leave these things as a surd rather than write them as a great big long decimal. So if we now do the next side, which is BC, so we're now using these two coordinates. So exactly the same principle, put in the values, there we go. And being as we've got to prove that ABCD is a rectangle, I'm quite happy to see the fact that we've got two different values. Okay, because we've got essentially what is AB is going to be our long side, BC is going to be the shorter side. Hopefully we'll find the next one, CD. With any luck, we'll find out that this has got a square root of 80, so let's see what happens. So we're using CD now. Put in the coordinates. And there you go. That's what we were looking for. And finally, the last one, DA. In they go. And there we go. So, what we proved is that we've got two pairs of equal sides, but have we actually proved that this is a rectangle? Well, if you have a bit of a think, you'll hopefully very quickly realise that there's another shape that has got two pairs of equal sides, and that would be a parallelogram. So far we've proved that we've got a parallelogram, but we haven't proved we've got a rectangle. So what we need to do is prove that we've got right angles, because if we can show we've got right angles, i.e. the gradients of these lines are perpendicular, then we know it's a rectangle, not a parallelogram. So we need to do a little bit of work on perpendicular gradients. So here we go. let's first of all find the gradient of AB, and we can do that using our formula, difference between the y coordinates over difference between the x coordinates for AB. So it's 5 minus 1 minus 7, minus 1 minus the 7. And so the gradient of AB equals minus a half. Gradient of BC, so using these two coordinates, put in the values, you can see where they're coming from hopefully, and work it out, and we've got a gradient of 2. Now, here's the important bit. We've now got to state, and we've got to clearly tell the examiner we know what this tells us. So what we're saying here is that minus 1 over 2 times by 2, so minus a half times 2 equals minus 1. That's our M1, M2 equals minus 1. So we're clearly stating that, and then we're putting a statement in there saying, yeah, we know what that means, and it means that AB and BC are perpendicular, and if it means they're perpendicular, therefore it can't be a parallelogram, so we have proved that ABCD is in fact a rectangle. So again, what we've done is used the Pythagoras formula for distance between 2 points and a little bit of work on gradient to do essentially what is a geometric proof to prove that the shape we got was a rectangle in this particular case.
Right, so let's have a look at how we could be asked to use some of the skills we've just been looking at. So we've got a question here. We've got a line L passing through a midpoint that's perpendicular to the 2 points that are given. And straight away with that, there's a whole world of information there that's just too much for my tiny mind to process. So let's try and break it down and figure out exactly what we're being asked to do. The first thing we're being asked to do is find the equation of a line. So we need the equation of L1. That's the bit up here. So what we've got to do is we have got to find the key information we need for that, and so we need to find firstly a gradient and secondly a particular coordinate. So where are we going to get that information from? Well, gradients, it's going to have to come from these two coordinates here. Okay, so coordinate A and coordinate B, and we're also given this extra piece of information that's perpendicular to AB. So let's find the gradient of AB, and then let's worry about how we find a perpendicular gradient. So that's the first thing we're going to do. So gradient of AB, using our formula, y2 minus y1 over x2 minus x1. Plug in the values. You can see I've picked the values from coordinates A and B up there. And so that gives us a gradient of 5 over 2. So we know gradient of AB is 5 over 2. And we're told in the question the line we want is perpendicular to AB. So using M1, M2 equals minus 1. That gives us the gradient of L1 is minus 2 over 5. So that's our first piece of information. We need the gradient. We've got that now. Let's go for the second piece of information. We need the coordinate. And we are told it passes through the midpoint M of those 2 points. So let's find M. There we go. So our midpoint formula, add them together, the x coordinates together, divide by 2. Add the y coordinates together, divide by 2. And so there is our midpoint. And so now we've got the 2 bits of information we need. So what we're going to do there is just bang those straight into y minus y1 equals x minus x1 at the point 3, 1. Chuck all the information in. There we go. And then the last thing to do is just tidy that up. We're told specifically we need it in this format here. Ax plus by plus c equals 0. So let's start by multiplying the 5 out. Take this 5 over to the other side. And I'm going to multiply out the minus 2 out of the brackets as well. So just take a moment to have a look and make sure you're happy where all those bits and pieces have come from. And then finally tidy it up, and I like to make sure my x symbol I like to make positive, so this time I'm going to take the minus 2x over to the other side and bring everything over to that left hand side, and so there we go, there's the equation of my line. So that's part A done and sorted. On we go to part B. So now we've got more information. We're told we've got another point that's on the line. We need to find the area of triangle CMB. And again, I'm struggling to see what's going on with this. So the first thing I'm going to do is draw a sketch and just have a little look at what all this looks like and make sure I know what I'm doing. So here we go. It's a sketch. It's not a piece of artwork. We don't have to put scales on our gradients. It's just I've put in points A and B and the line in between, so approximately where they're going to be. There's going to be no marks for this. It's just about helping me understand what I need to do. Let's put in point M at 3, 1. There it is. We've now got our point C, which is at 13 minus 3. That's down there somewhere. The line L1, that goes to those two. There we go. And now we want triangle CMB. So now we can see it's CMB. There we go. There's our triangle. I'm going to just bang that in and shade it in. Now I can see what's going on. So, area of a triangle, I'm going to use half base times height, And clearly we've got, because we know that the red line and the blue line are perpendicular, that means the angle at M is a right angle, so I can use my base and height. So I can have height being MB, base being MC. How I'm going to find those lengths? Well, I'm going to use Pythagoras. So there's MB, again, putting in the points from our formula. x2 minus x1 squared plus y2 minus y1 squared, using the points M and B. And again, you might want to just pause and take a little look at where I'm getting all those values from. That gives me the length of MB, root 29. MC, done in exactly the same way. Bang that into the calculator. We've got 2 root 29. And so now I can do my half base times height. Half root 29 times by 2 root 29. So the whole thing works out to have a value of 29 units square. And there we go. There's part B done. Right, on to the next question we go.
And here we've got another similar question. So this one is taken from the exam, so an exam style question. So first things first, we're told that we've got the points Q and R, the line L1, there we go. And we're told the length of QR is this thing here. So it's a multiple of root 5. We've just got to work out what the value of A is. So we need the length of QR. So there's our formula. Put in our points. And there you go. We've got it as a surd root 45. So all we've got to do now is break that surd down. So that becomes 3 root 5. So there you go. Our value of A is 3. We're then told we've got L2. There it is. Perpendicular to L1. And we need to find an equation for the line. So it cuts through at Q. So again, for our equation of the line, we've got the point, which is Q, and we'll be able to get the gradient of L2 by using the gradient of L1. So here we go. Gradient of L1, there it is minus a half. And so that means since M1, M2 equals minus 1, using our negative reciprocal, the gradient of L2 is simply going to be 2. Now you'll notice in this one it just says find an equation for L2. We don't have to write it in any particular form, we've just got to write the equation. So using the point 1, 3, let's put in our values. And because we haven't got to put it in a specific format, what you've got there is an equation linking the x-coordinate, where is it, there we go, the x-coordinate and the y-coordinate. Most people would multiply out the brackets and do a bit of rearranging, but you really don't need to. You're doing extra work for no real extra credit there. That thing there is an equation for L2, so that will do nicely. Right, so part A done, part B done. On to part C. We need the coordinates of P, and that's where it goes to the y-axis. There it is. So where it goes to the y-axis, the x-coordinate is 0. So if we just put 0 into our equation here, you've got that. And so there's the y-coordinate, which is at 1. So asked specifically for coordinates, so I would restate those, so our coordinates of P are going to be at 0, 1. And finally, on we go to part D, where we've got to find the area of PQR. So let's have a look at that. So we know that L1 and L2 are perpendicular, so we've got a right angle at Q. So that's the right angle triangle that we're going to have to find the area of. We've already got the length of QR, which was 3 root 5. So what we're going to need is PQ, that length there, and then we've got half base times height again. You will find in most exam questions that you do tend to end up with right angle triangles that you've got to deal with in coordinate geometry questions. So what I'm going to do is just take that triangle and just kind of redraw it so I can see what's going on. We already know that QR is 3 root 5. We need to find PQ. And if we know that Q is at 1, 3, P is at 0, 1, we can just pop those numbers into our formula. There we go. So the length of PQ is root 5. There it is. And so now it's a straightforward enough job just to do half base times height. So here we go. Half times the base, root 5 times by 3 root 5. Hopefully we're happy that root 5 times root 5 is just 5. So we've got half times 3 times 5, which is 15 over 2. And we're all done.